Okay. Hello, can you hear me?
Yes, yes.
Okay. So we will start today's session. Just a minute. So I start the recording option. Okay. Okay. So now can you see my screen? Can you see my screen now? Hello.
Yes, I can.
Okay. So basically today is our third day online training session, and we already covered our first day and second day. So mainly in the first day and second day, we will try to discuss all of the topics for a beginners, how we can easily learn the programming language of JavaScript. Then we also second day's class we also try to complete that how you can easily filtering and displaying the satellite images. Okay, so we will cover all of the parts of all of the basic part in our first day and second day. So mainly today's class I also try to show you that all of the things for how you can easily make the land cover classification map, as well as how you can easily make the air quality map, and how you can easily make the calculating the area. Okay, and use the different types of machine learning algorithm for creating the land cover classification map. Okay, so let's go our today's class. So I simply open my slide. Okay. So hi and welcome to the third day online training session on Google Earth Engine for beginners course. So mainly this course I take the 3 days, and we already covered the 2 days, and today is our third day class. And today I am course coordinator. So today our course content will be that first of all I will try to discuss about that computation using satellite images. So mainly in this part I will try to discuss how you can easily calculate the different types of indices, NDVI, NDWI or EVI from the satellite images. Okay, suppose you want you take a satellite image, it can be Landsat or Sentinel or any image you want to take, and then how you can easily calculate it. And then I also try to discuss about that land cover classification map. So mainly in this time here I discuss how we can easily make the land cover classification map using the satellite images, different types of satellite images. Okay, so then I also try to discuss about that how we can easily make the LULC map in Google Earth Engine platform. Okay, and then I also try to discuss about that how you can easily export the map as a TIFF format. You can export the map as a TIFF format, and then how we can easily work with the ArcMap software for making the map layout and other things, how you can easily make the map for your research paper or your presentation work. Then I also try to discuss about the air quality monitoring. So mainly in this time here I discuss about the different types of air quality parameter, such as sulfur dioxide, nitrogen dioxide or other things. So just a minute. Okay. Okay, so we will try to discuss all of the things, and then finally we can talk about that how we can easily filtering and displaying the Sentinel-2 imagery and calculated the NDWI. Okay, so mainly NDWI, how we can easily calculate the NDWI, we also try to discuss about this. Okay, so first of all, introduction to land cover classification map. So mainly what is land cover classification? Land cover classification can be defined as the observed or biophysical cover of the Earth's surface. And we can use the land use and land cover data. We can easily compare the document of land use, trends and change. We can easily understand what is the change on our specific land from the land use and land cover data. Okay, we can easily make the change detection map from here. So today we will try to discuss about this, how you can easily make the land cover classification map. So first of all, what's the process when you want to create the land cover classification map? What is the process you want to follow using the Google Earth Engine platform? So in this time I will try to discuss about this, what is the process. First of all, and the first step is that you need to selecting your ROI. So you select your ROI. This is your region of interest. Suppose you want to make the land cover classification map for country boundary of Bangladesh. So this is your ROI or region of interest. You want to create the land cover classification map for the Dhaka city. So this is your ROI for the Dhaka city boundary. You want to create a map for India, whole country boundary of India. So this is the ROI for your India country boundary shape file. Okay, and this is the first step. Then you need to choosing and filtering the image collection. Suppose in this part you need to filter. You need to filter your image collection. It can be Landsat, it can be Sentinel, different time period image or different club image properties you also filter. Okay, so second step is that you choose your image and filter your image collection according to your properties. And then third process, from the satellite images you also need to collect some training point. You want to take the training point. Suppose you take the training point for the water body, you can take the some training point for the urban area, you take the some training point for the barren land, or what class you want to classify, you take the training point from the satellite images. Because in this time here I apply the supervised classification. So when you want to make the supervised classification, you must be include your training point, then you need to work. Okay, so we collect the training point, a specific training point. This training point help to make my supervised classification map using the machine learning. So I take the training point for my all of the classes, which class I want to make the land classified or make the land cover classification map. So I simply collecting the training point, and then I also need to I need to merge all of the training point together. So merging all of the training point together, and then I need to make a training data set by sample region function. So in this time I take here the every band value, spectral band value. I take the spectral signature of all the prediction band. I take the spectral signature all of the prediction band and created the training data set. Okay, and then I use the training data set. I create the classifier and classify the image using this training data set, and then created the classified image, and then finally display the result. And then we also need to calculate the specific area of each classes, and we also need to use here the accuracy assessment. Okay, and last step is that we need to check our accuracy. What is the accuracy of our map? We can make the confusion matrix table, and then we can easily calculate the overall accuracy for this map. Okay, so let's go. We will try to follow all of the step by step, and then we can create the land cover classification map in Google Earth Engine platform. So here you can see a small project of land cover classification map. So mainly you can see here I classified the water body, built up area, then vegetation, then bare land. So this is the code link. You can easily go to this code link and get this code. And this is the another map you can see. This is the Dhaka city land cover classification map. So mainly in this map I created in Google Earth Engine platform. So here you can see here I defined the build up area, also water body, also classified the vegetation and barren land. And you can see also calculated the area. What is the area for the water body? What is the area for the build up area? What is the area for the vegetation? And finally, what is the area for the barren land? Okay, so let's go. In this time, we will try to go to our code editor and try to practical how we can easily work with this. So I simply open a new code editor in here. In this time you can see I simply open my code editor, and first of all I need to import my region of interest. Okay, so in this time I simply import my region of interest in here. So we already know about that, how we can easily import our shapefile, we already covered this part. So in this time I simply import my shapefile. Suppose I want to create the land cover classification map for the Dhaka city. So I simply import the Dhaka city shapefile or Dhaka city boundary shapefile. I simply click to here, it will be import. You can see it will be imported in my Dhaka city shapefile. Okay, so in this time I simply change the name of that ROI. So I simply change the name. Suppose this name is that ROI. Okay, you can use any name, it's totally depend on you, because this is the variable, and variable name can be anything. Okay, so in this time I simply select my ROI. So my first step is done. You can see I want to show my ROI in here. So I simply use here the map.add layer, and then I simply call my ROI. This is my object name, ROI. Okay, and then I also want to add here the map.center object. Okay, and then I simply put here the ROI, and then I use here the 10, and then click to the run. So now you can see what happened. This is my region of interest. You can see now it will be display my region of interest. In this region, for this region I want to create the land cover classification map, and I want to classify the built up area, water body, vegetation, and barren land. Okay, so this is my study area. In this time I simply import my ROI, and then I also need to import my image collection, which image I want to use for making the land cover classification map. If you want, you can use the Sentinel. If you want, you can use the Landsat, and both images are the same process. Okay, so in this time I simply use here the Landsat image. Suppose I simply search here the Landsat 8. Okay, so I simply browse the data catalog. You can see browse the data catalog. Simply click to here. So now it will be provide me all of the data set for Earth Engine public data catalog. In this time I simply go to the Landsat. Here I find lot of Landsat image collection, you can see. And in this time, suppose I want to work with the Landsat 8, I simply click on the Landsat 8, and all of the Landsat collection it will be appeared. You can see Landsat surface reflectance, Landsat top of atmospheric, Landsat raw image. Which image you want to need, you can simply work with this image. So in this time I want to create the land cover classification map using the top of atmospheric imagery. So I simply click on the top of atmospheric. So you can see it will be open, and here I can get all of the information about the top of atmospheric dataset for Landsat 8. Okay, here I can get all the things. You can see dataset availability date, dataset provider. This dataset provider is the US GIS and Google, and Earth Engine snippet. You can see Earth Engine snippet. Okay, and all of the band you can see, also their resolution and also their wavelength. You can see. In this time, first of all, I need to import my collection in code editor. So this I simply copy this Earth Engine snippet from here, and then I simply paste in my code editor. I simply paste. Okay, I simply paste in my code editor in here, and I simply take a variable in here. So I simply take the variable and give the variable name is the L8. In this time, what happened, you can see this is my full collection of Landsat 8, and this collection is stored in a variable L8. Okay, so in this time I want to filter this image collection. So second day's class or previous class, second day's class, I try to discuss about that, how you can easily filtering the image collection, how we can filtering the image collection according to the filter bounds function, using the filter date function, using the filter metadata function. I already covered all of the function and description in our previous class. So in this time I just write the code for the filtering. I hope you can easily understand. I simply take a variable and give the variable name is the image. Okay, I simply call my whole collection L8. I want to filter, I want to use here the filter bounds function. So that's why my full collection is intersecting with my ROI. What is my ROI? You can see this. This is my shapefile variable name, ROI. I simply use here the ROI. Okay. Then I also want to use here the another. This is the called the filter metadata. Okay. And what is the filter metadata? In this time here I put the image properties name. Image property is the cloud cover. And what is the operator? I want to need only for the less than 1% cloud cover. I simply use here the less than, and suppose I need the less than 1% cloud cover. I simply use here the 1. And then I also want to create, suppose I want to create the Landcover classification map for year of 2021. Okay, so I simply use here the filter date function, and I simply put here the start date and end date. What is my start date? My start date is that year of 2021, 1st January. Okay, and end date will be that I simply put here the end date 2021 December 31. Okay, so here I can get a lot of you can see how many images I want to get from here. I want to get from here, you can see I simply copy the image ID, simply copy, and then I simply use here the size function and then click to the run. So now you can see how many images is available for year of 2001. We can get the total 4 images. This 4 images is less than 1% cloud cover, and it will be straight in my region of interest, and it will be belongs to this year. Okay, I want to get from here. I want to use all of the images, and if you want, you can also use the single image. So previous class I also try to discuss about that, how you can easily use the single image or single date image. In this time I want to create the composite, all of the image using the median function. So it will be created the median pixel value composite from these 4 images. And I also want to use here the clip function. So I simply use here the clip. It will be clip with my shapefile. My shapefile variable name is that ROI. Okay, and then I simply use here the map dot add layer. And what is my object name in this time? My object is that image, and I add the visualization parameter later. So I simply remove all of the things and then click to the run. So now we can see it added a satellite image in my area. So now it will be added, you can see. Okay, so it will be added a satellite image, but this image is not good. Okay, in this time I want to add here the visualization parameter. So I can get all of the visualization parameter from here. So I simply click to here. I simply go to the B4 red band, B3 green band, and B2 blue band, and I also increase the stress 98% and click to the apply. In this time you can see what happened. We can get the natural color of this satellite imagery. You can see I take the natural color of satellite imagery in here. Okay, so now I can easily use this satellite imagery for making the Landcover classification map. Okay, and in this time you can see I simply import, click to the import for the visualization parameter. I want to import the visualization parameter in my code editor. So I simply click to the import. You can see a new line of code will be added here. I simply copy the visualization parameter from here, simply copy, and then simply paste here. Okay, and I give a layer name. Suppose this is the true color composite. Okay, now you can see it will be added with a set the visualization with my images. You can see. Okay, so you can see this is my satellite images I can get. So this is my second step is done. First step is that you need to selecting your ROI. Second step is that filtering and choosing the satellite images. Filtering and choosing the satellite images. Okay, so I simply selected and filtering and choosing my satellite images in here. Okay, in this time my third step, you can see what is my third step. My third step is that collecting the training point. I need to collect some training point for every classes, for water body, vegetation, build up area, barren land. I take the training point for each classes. So what is the process for collecting the training point? You can see this is my images. I take the training point from this Landsat images. Okay, suppose I take the images for the water body. You can simply click on the marker. You can see add a marker, click to here, and you can see a geometry will be added here. Simply click to the edit layer properties. Then you can simply change the, suppose I want to take the training point for the water, so I simply take the water. Okay, and then import as feature collection, select the imported feature collection. Then property, you can simply select the property, suppose class, and value is that 0. Okay, so it means that here you can see I take the training point for water, and all of the training point value is 0, and property is the class. Okay, so all of the training point value is 0. Okay, so in this time simply click to here, and then I simply, you can see water also added here. So I simply take the training point from here. You can see here I find out the some water body in this satellite images. You can see I take the training point from the satellite images. You can see this is the water body, this is the water body, this is the water body. So I simply take the some training point for the water body. Okay, I take the training point for the water body. In this time I want to take the training point for the build up area. Okay, so I simply click to the new layer, and then I simply click to the edit proper layer. So then I simply put the geometry is that build up area, build up. Okay, then import as feature collection. Property name is the class, property name will be same, but in this time all of the training point for the build up area I assign the value is the 1. So 1, this is the value for all of the training point of build up area. I simply click to the OK. Yeah,
I have one question.
Yeah, you can ask me.
Can we start the value from like 1? Like just like you start the value from 0. So can we start this from 1?
Okay, no problem. Actually, this is the sequence. Okay, so if you want, you can also start the 1. If you want, also you can start the 4, 5. Just you can maintain the sequence. But here we use the 0 because we already know about that JavaScript programming language is the 0 base. So it will be start to the counting from the 0. First of all 0, then 1, then 2, then 3, just like way. So in this time, here you can see I simply take the training point for the build up area 1. So I simply take the training point for the build up area.
Please, another question.
Okay, any question? You can ask me. Any question, anyone?
Yeah, okay. Why did you color water body in red? As you know that usually on map they color water body in blue.
Okay, okay. So in this time, you can take the good question. How I can understand about this is the water body? Okay, so we can use the different types of feature using the different types of band combination. In this time, here you can see here I use the band combination for red, then green, then blue. Okay, so this is the 3 band combination, and it created the natural color. It created the natural color. Okay, and if you want to know more about the band combination, you can see I simply open this link, and from this link here you can get all of the band combination. Suppose true colors, false color. So mainly we can use the different types of band combination for identify the different types of feature. So here you can see this is the band combination for 432 or red, green and blue. It's called the natural color, and natural color composite uses a band combination red, green and blue. It replicates the close to what our human eyes can see. Healthy vegetation is green, unhealthy flora is brown, and urban feature white. Urban feature is white. Okay, so it will, when you use this band combination, you can see the urban feature as a white color, like this color. It is the urban feature, or gray color. Okay, and water is the dark blue or black. water can be dark blue or black. So here you can see I use the red green B4 and B3 and B2 band combination, and here I can easily understand. You can see this is the white, it will be identify the built up area, and this is the black dark blue color, so I can easily identify this is the water body. And also I can see here, you can see healthy vegetation as showing the green color, so this is the vegetation is the green color. Okay, if you want you can also use the another band combination. Here you can see it's called the near infrared band, red band and green band. Okay, it's called the combination of the false color composite, and when you use this band combination, then I can see here the you can see the areas in red area identify the better vegetation or healthy vegetation. So red pixel value identify the better vegetation, and dark areas are the water, and urban area as the white. So I want to use the band combination. Wait a minute. So you can see 5 4 3. So I simply use here the 5, then 4, and then 3, and also stretch the state 98%, and then click to the apply. So now you can see what happened. Healthy vegetation is showing as a red color. Okay, you can see healthy vegetation showing as a red color. In this area you can see healthy vegetation showing the red color, and water body showing the dark color, and urban as a showing the white color pixel value. Okay, here you can see we can easily identify using this band combination. For the you can see dark areas are water body, urban areas are white, and healthy vegetation is showing the red color. Okay, also you can see this is the another band combination, short wave infrared. So this is the 764. When you use this band combination, so mainly we can use the band combination for the green and indicated the denser vegetation, sparse vegetation has a lighter shade, and urban areas are blue. You can see when you use this band combination, then urban areas will be show as a blue color. Okay, urban area will be show the blue color when you use this band combination. So here you can see it will be showing the blue color, so it identify this is the urban area. And soil have various shadow of the brown, soil can showing as the brown color. Also you can see this is the another index for the agriculture. When you use the 652, it identify the mainly used for the agriculture field, identify the agriculture field, we can use the band combination. So healthy vegetation appears a dark green, and but bare earth as the magenta hues. Okay, so this is the another band combination. You can see this is the geological band combination. So mainly when you can use the band combination 762, it mainly used for the this band combination is particularly used for identify the geological formation, lithology feature and faults. Okay, also you can see the bathymetric. Okay, so here you can it will be help for the bathymetric. Okay, in the coastal area bathymetric aerosol study is the reflects the blue and violets. Okay, you can see panchrometric. Okay, also you can see vegetation index, so mainly we can use the vegetation index for identify the vegetation. Okay, also you can see moisture index. Okay, we can mainly use the moisture index, estimate the amount of the moisture content in the water body. Okay, so we can easily water appear as a blue color, you can see in here. Actually a lot of indices we can use here, so you can just simply go to this link, then you can also showing the details information about the band combination, and you can using the different types of band combination you can easily take the training point like this. Okay, so if you have any question in this time you can ask me any question, any doubt about this for the band combination. Any question?
I have no question.
Okay. So mainly we use the different types of band combination for identifying the different types of feature in the earth surface. Okay, so here you can see in this time when I use the band combination I can easily identify this is the build-up area because this is the fall color composite. Okay, so easily identify. So I simply take the turning point for the build-up area. Okay, in this time I take the turning point of the vegetation. So I simply click to here, and then I simply take the geometry as the vegetation, and then I simply import as the feature collection, and property name will be same for the class, and in this time it will be 0 1 and it is the 2. Okay, so I simply click to here, and when you use the band combination for the 5 4 3, it is the false color composite, and in the false color composite, red color identify the better vegetation. So I simply take the some training point for the, you can from here. Okay, so I take the training point for the vegetation. Okay, so in this time, suppose in this time I also want to take the some training point for the barren land area. Okay, I simply take the new layer, and then I simply go to this edit properties, layer properties, and that this is the barren land, and then I simply import as the geometry is the feature collection, and property it will be simply use the class, and value is that 3. Okay, in this time I simply take the barren land from here, you can see. So this is the only for the space empty land. Okay, so you can easily identify from here some barren land, also some barren land in here. Okay, so I take the training point for the barren land. Okay, you can see. So now you can see here I can get the training point, all of the training point from here, and now I can easily use this training point for make my training data set. Okay, so you can see I take the training point. So in this time here I can use merge. You can see our third step is the done. So our third step is the collecting the training point. It will be done. Okay, I take the training point for my each of classes. In this time merging the training point, I need the merge all of the training point. So how I can merge? So I simply take a variable. Suppose I simply put the variable name is that training. You can use any name. I simply use here the training. Okay, then I simply merge. So I want to use here the water. It will be merge with build up area. Then also use here the merge with vegetation. Also use here the merge with barren land. So I merge all of the training point. I want to check what is the condition about the training point. I want to check it. So I simply print, and then I simply copy the variable name and paste here. In this time you can see our console tab. Here you can see, here I collect the total 95 training point for all of the classes. Okay, you can check it, 95 training point. You can see all of the training point here I can get. Suppose you can see the 23. I want to check it. What is the training point? What's the class for this training point? I simply click to here and click on the property. Here you can see it will be showing the class 0. So it means that this training point is the 0. It means that this training point is for water body, because you can see when I take the water body, I simply use here this value is the 0. Okay, I want to check what is the class for the 61. Simply click the properties. You can see this is a class 2. It means that this 61, this training point is for vegetation, because you can see when I take the training point, I can put the vegetation training point, I can put here the value 2. Okay, so all of the training point with their value I get total 95. Okay, in this time I want to add here the prediction band. All of my prediction band I want to add here, and then I want to take their spectral signature and created the training dataset. Then using this data set, I use the machine learning method for calculating, making the land cover classification map. Okay. So in this time, I want to create the training point. Okay. So for the training data set, I simply use here the another things you can see. So first of all, I simply I want to create. I simply write the comment so that you can easily understand. Create the training data set. Okay. So for this, I simply take a variable. This variable name is that level. Okay. And I want to use here the what is the level? Level is my class. Which property name? This is the property name. I simply use here the class. Okay. Then I simply use here the take a variable name is the bands, and then I simply store all of the band in here. Suppose you can see I as a prediction band, I want to use all of the band. You can see B1, B2, B3, B4, B5, B7, B8. I take all of the band value for every each single training point. So I simply use here the, you can see, as a prediction band, I want to use here the B1, also use here the B2, also use here the B3, also use here the B4, also use here the B5, also use here the B6, and finally I simply use here the B7. If you want, you can also add here the external band. External band is that, suppose I want to add here the another band for the NDVI. Suppose I want to add here the another band for NDWI. Suppose I want to add here the another band for NDCI. Suppose I want to another band for the BI index or build up index. You can see this is the internal band. This is the internal band, and this band is already exist in my satellite images, but this band is not exist in my satellite images. This is the totally external band. Okay, so when you want to use the external band, then you also need to create it, this external band. Okay, so this is our beginners part, so that's why in this time I will not showing this part for how you can easily add the NDVI, NDWI, NDCI and BI as a prediction band. Okay, so this is a totally beginners class. So in the next advanced classes, if you want to join, then you can easily learn all of the things for how you can easily add the NDVI, NDWI, NDCI and BI index, and you can get the more accurate land cover classification map. So in this time I simply ignore the all of the external band. Okay, I use in the only for the internal band and create my land cover classification map. Okay, so in this time I want to take my input, so I take the variable and give the variable name is the input. Okay, then where I can get the input, I want to get the input from my image. So this is my image, so I simply call my image, because this Landsat Edge image is stored in the image variable. So I simply call him and paste here, and I want to select from here the bands. So I simply copy the bands and paste here. Okay, so now I can simply create my training data set. Okay, in this time I want to create the training data set for all of the pixel value. You can see here I can get add all of the band as a prediction band. I added all of the band. In this time I want to need that 95 images for the 95 training point. I want to need all of the band value. For B1 I need B2, B3, B4, B6, B7, all of the spectral signature I want to need for every each training point. Okay, so for this I simply use a function. It's called the sample regions function. Okay, so for this I simply take the variable and give the variable name is the train image. Okay, you can easily name any name, no problem. Then I simply call my input. Because it is stored my image with my specific band. Then I simply use here the sample regions. Okay, then you can see what is the argument. Here I can get all of the argument. I simply created the dictionary. I simply use here the curly bracket start and curly bracket int. So I make a dictionary. And then first of all the collection. Your collection, you want to take the training point. So in this time, what is the training point? You can see I already merged all of the training point and stored the variable training. So I simply use the training and paste here. Then properties. So property name is that your property name is the class. Okay, your property name is the class. In this time, I already defined the class in a variable. This variable name is the level. I simply copy the level and paste here. Then class scale. Scale is the resolution of your satellite images for Landsat 8, 38 meter. Projection not needed, so I simply remove it. Okay, so in this time I want to just print, so I simply use the print this training image. So I simply print. In this time, here you can see this is my training data set, and here I can get all of the spectral signature value. You can see for every individual point. For the 95 training point, I take the all of the, you can see, I simply click to here. When I click to the 0 number point, you can see this is a 0 number of point. Click to here. Here I can get, you can see what is the spectral signature for the B1, B2, B3, B4, B5, B6 and B7. All of the training point I can get for the class number 0. So 0 is identify the water training point. So all of the 95, total 95, all of the training point, I can take the spectral signature value. Okay, so you can say I take the all of the value. For all of the training point, I take the all of the value. So if you want, you can also add here the NDVI, NDWI, NDCI or BI, all of the index. Then your map result is the more accurate. Okay, then you can get the better Landcover classification map. But in this time, this is the totally introductory part class, so that's why I will ignore this part. And if you want, you can also join my advanced training session on the Google Earth Engine for the Landcover classification. Then you can easily understand all of the things, how you can easily add the NDVI, NDWI or other things. Then you can easily understand all the advanced Landcover classification class. Okay, so here you can see, here I can get all of the training data set. You can see for B1, B3, B7, I take the I get all of the training spectral signature with their value of the band value. Okay, in this time I want to use this training point or training data set for making the Landcover classification map. Okay, and use the machine learning method, using the machine learning method. So in this time, if you have any question regarding this part, you can ask me any question or any doubt. Anyone, any question or any doubt about this or any confusion?
So this was the land use land cover classification. Like we didn't see the results.
Okay. Any question? Okay, so let's go start. No, okay. So in this time here you can see we created our training data set. In this time, I want to run this training data set with my different types of machine learning. And in this time, Google Earth Engine has already added the training classifier. You can see when I go to the classifier, here you can see I simply search at the classifier. Here I can get all of the classifier or machine learning method. Here I can easily get, you can see this is the decision tree, then support vector machine, then minimum distance, classification and regression trees, minimum distance, random forest classifier, spectral region classifier. All of the classifier I can get easily from here, and every classifier has the every individual part. Okay, so this is our introductory part, so that's why I will not go in the depth for the classifier. I can simply use a one classifier, and then I want to take the training my dataset and create the Landcover classification map. Okay, so let's go. Suppose in this time I want to create the Landcover classification map using the this classifier. This classifier is the classification and regression trees. I want to use this machine learning method for the mapping the classification and regression trees for making the Landcover classification map for this region of Dhaka city. Okay, so let's go how we can easily do this.